Hello, everyone, and thank you for listening to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist, 3D printing enthusiast, and owner of Ascent Fabrication. Fabrication Friday is an all-around fun time where I talk about 3D printing applications, conduct interviews with industry leaders, and much more. Come join us every Friday for an informational discussion around the evolution of the additive manufacturing field and how we utilize various digital workflows and 3D printing methods in our daily work at Ascent Fabrication. All right, how's it going, everyone? Joe Fairley here from Ascent Fabrication. You are watching and tuning into the Fabrication Friday podcast. It's July somehow. We're more than halfway through the year. It feels like the first half of the year has flown by. And in July, I have to give some thanks and kudos to the O&P Edge magazine. For those who are watching the video right now, holding up their July issue, we've got the front page, two of our sockets, the Foam Flex Air socket and a test socket base mode printed from PETG, Filament Innovations, high flow FDM printers. Go check out Filament Innovations, got to plug them all the time. But thank you to the O&P Edge for this cover. That's beautiful. Thank you very much for that. Judith Phillips Auto did an interview with me, and a lot of the interview was used in this definitive article. So taking a look at what constitutes a definitive lower limb prosthetic socket. Right now, no standards exist for a definitive laminated carbon fiber socket to test it. So there has been a little bit more in terms of actual cyclic testing that has gone on. There is a multidisciplinary team from AOPA, the American Orthotic and Prosthetic Association, the Socket Guidance Work Group. And a Socket Guidance Work Group, I know, is led by a number of individuals, one of which, name dropping here, Jeff Aronstone, CPO, and 3D printing enthusiast, very knowledgeable in that regard. And they have started to do some type of cyclic testing on what constitutes a definitive socket, because having something now 3D printed, one of the biggest questions that we get out of Ascent Fabrication is, well, okay, you can print this device. What materials are it made out of, and how long does it last? So if you're looking for a nice article that is written from a number of different individuals in the field who are very knowledgeable on 3D printing in general and how we're using it in a clinical sense, please take a look at the July issue of the O&P Edge magazine. So thanks again to Judith for interviewing me for that article. And today I have the esteemed pleasure of bringing on Mitch Debora here, the co-founder and CEO of Mosaic Manufacturing. Mosaic Manufacturing has a lot going on right now, some exciting new stuff with 3D printers, other additions to 3D printers that could be used. So thanks again, Mitch, for coming on today.
Thanks for having me, Joe. Excited to talk about the state of 3D printing and where things are heading.
Yeah, absolutely. So, with that in mind, where did you, kind of get involved with the 3D printing industry in general? When was that? How was that? How did that come about?
It's a good question. I think I have one of those kind of classic founder stories of discovering a problem and then before you know it, trying to solve it. Takes me back, actually, I think it's 12 or 13 years ago. I was studying mechanical engineering, and in one of the courses, in one random moment, the prof had a slide up and they said, rapid prototyping using 3D printing. And I was like, what does that mean? I didn't know what a 3D printer was. No one talked about it. And I started doing a lot of Googling, and I found, I got really lucky. The timing, MakerBot was just coming out. Printers were just getting a lot more affordable. And I became pretty obsessed with it. I needed to find a way to buy one. So having grown up in kind of an entrepreneurial household, I saw it as an opportunity. What if I buy a printer? I saw the value right away, start a Wix website, position myself as someone who can print as a service, and saved up some money, did that, got my first Maker Gear M2 in my dorm room at Queen's University, and started, printing for students and professors. And before I knew it, automotive and medical companies were buying parts. And I got to really sort of pay for that printer and really discover the power of 3D printing, but also some of the limitations. And the first one that really caught my attention was the single material limitation of most FFF printers. There was
Mm-hmm.
this one time when a customer, they were an automotive company, and they said, I will pay you 10 times as much if you can print this part in 3 colors. They needed that for a safety standard. And I said, I would love to print you this $3,000 part, but printers don't do that. Even dual extrusion, it's not very reliable. So I had to say no. And that kind of, in some ways, became the impetus for starting Mosaic.
That's awesome. Yeah. I mean, with the FDM layer by layer approach, single nozzle extrusion, with the consumer level desktop printers that initially came on the market, I think that spurred a lot of aha moments and interest in a lot of people. It sure did for me as well. Had a very interesting, kind of upbringing in that sense. So with that, you said the Prusa MK2, was that it? That was the first printer you had?
Sorry, actually, even before I think Prusas were popularized, this was the Maker Gear
Maker,
M2,
yeah.
Maker Gear company out of Ohio, and yeah, it made a
Yeah.
really bulletproof printer, and it was great.
Nice, nice. So was that the only printer that you were using at that time? Did you add on a second printer, or how did that kind of develop as you started to take on more clients?
It's funny actually. I hadn't thought about this in a long time, but at the university they had a couple, really expensive, the kind of printer where a spool of ABS is $350, and so I would try and leverage that, but I often found they would actually send jobs to me because they're like, no one wants to print when it's this expensive, and so we try and leverage the university resources a bit where possible for student projects, but that ended up coming full circle to me printing them. Um, when we eventually started Mosaic, we joined a startup incubator at the university and looked at problems we wanted to solve, and multicolor 3D printing became the start of that. So I think we then went out and bought a couple more low-cost printers for the very, very pragmatic purpose of being able to, one, develop our products, and two, test our products, because as I think one of the first products we came out with was called Palette. And our go-to-market strategy on that was very different than just making a printer. Instead, we made an accessory that can be used with almost any printer in the market. So, if you own a printer, you can add a palette to it, and it brings multicolor, multi-material 3D printing to that printer. We're on our 5th generation today. It's called Palette 3. It's on the market. There's tens of thousands of these out in the world. So, spoiler, it was a long, challenging journey, but we were able to kind of develop the IP, bring that product to market, and develop a dominant market share for that to this day.
That is really cool. Again, multicolor 3D printing is pretty interesting. There aren't many printers, really on the market from FDM all the way up to MJF that can really do it. Not to mention that HP just pulled their full color printer from production. So, take me through that initial thought of trying to even go through slicing and the G code for multicolor 3D printing as much as you can tell me. I know there's a lot of IP wrapped up in it, but
yeah, no. It's funny. I'll start by saying, feedback we often got from early people we spoke to, whether it be investors or people in the space, or not in the space, they'd say, it seems so obvious. Of course, multicolor should be a thing of 3D printing. Why has no one else done it? We don't understand how you're going to be able to do it, but no one else has.
right.
And it was kind of a devil and a curse to find that it was such a challenging problem to solve. You just pointed out, the software, the slicing, the workflows, the integrations, the hardware, the certifications, you name it. They say hardware is hard, and building a profitable hardware business is I think Elon Musk said is next to impossible. So it was really challenging, but I think we had just such an amazing focus group of people that I was lucky to work with on this, and a group of mentors and advisors who could help us navigate the challenges of product development, manufacturing, fundraising, IP, you name it. And once we kind of got that escape velocity, we launched a Kickstarter campaign, raised just under $250,000, and that's when it all became very real. But the crazy thing is, that feels kind of like yesterday, but that was actually 9 years ago.
Right.
And, I think potentially even more relevant to the market of today would be jumping forward to maybe about 5 years ago, where we started to see something interesting, which is that, and I think there's many company stories where this happened, a customer started using your product for something you didn't intend.
Right. Yeah.
For us, yes, palette is marketed and designed for multicolor, multi-material, but inherently it's also automating the changing of filament. That's what it does,
Yeah.
right? And so we started to see a trend. First it was one, then it was five, then it was 20 companies who were buying not one palette, but many palettes, attaching it to many of their printers, whether it be high-end industrial printers or low-cost, $300 Creality Ender 3 kind of things. And the reason they were buying it is because they were building farms of printers to
Yeah.
scale 3D printing into production. And they realized that, a person going in to collect parts, to harvest parts from the printers, that's one thing. But if the person also has to go automatically change the filament over at unpredictable times, the
Hmm.
labor is so significant that the costs of the farm are really high. So they were buying pallet to automate the changing of filament. And that very much became um, a critical moment for us as a company, realizing that we could have an important part to play in this automation and scaling of 3D printing. But that was really just a portion of it. And with our array product that I can tell you some more about, we
Yeah.
really went all in to solving this problem of automated scalable 3D printing.
That is so neat. So yeah, that what you mentioned there with having a product out there where people, are doing something different than you intended it's used to be. I think that's almost just inherent to 3D printing now. We're kind of finding different ways to use the printers for different things. We've got a lot of that kind of going on in the prosthetics and orthotics field too, where we're manipulating different designs and different printers to do different things than some people otherwise intended them to be used for. So with the automation of automatic filament changing, that is definitely something that us as a central fabricator, a service contractor, we're going to be growing into the need for that already. There's been times where filament sensors are sometimes inherently unstable and unpredictable. I'd love to just be able to continue an entire print and not have to worry about that material running out, right? So that's in that sense of, they were running through kilogram after kilogram of material.
You got it. That's exactly it. It's don't get me wrong, the run out switch is much better than nothing. But as if you don't catch that within 10, 20 minutes, the thermodynamic process, you go out of equilibrium, and before you know it, now that part of the print is cooler. Then when it starts back up and that next layer becomes hotter, so you will end up with defects, structural imperfections, cosmetic imperfections. So
Right.
using palette, you were able to splice one end of a filament to the end of, sorry, the beginning of a new spool to the end of the old spool, having uninterrupted continuous printing.
Mm-hmm.
Meaning from the printer's perspective, nothing ever happened. It's just kind of this infinite spool. And yeah, it was kilograms after kilogram. But in all fairness, palette was not initially built for that. And so really lucky that we were able to leverage it for that purpose. But as people started getting into, more industrial grade materials, carbon fiber reinforced nylons or others, some really abrasive materials, or even high-end materials like Peak Pec Ultim that have such high temperatures, we reach the limits of what palette, at least the current generation of palette, can do.
Okay.
So in the array product, we ended up developing what we call Palette X, and it's really the industrialized version. It doesn't rely on a thermal process. It's a lot more friendly and universal to different materials, more friendly for flexible filaments, and gives us a lot more opportunity. But that was only possible because we kind of made that leap from making an accessory to other printers to building it into our own printer, which gave us a lot more flexibility. And like they say, when you're designing something for everybody, sometimes it kind of becomes not really specialized to any of them individually, but designing it to be integrated into our Element 3D printer, we were able to get a lot of efficiencies and just achieve simplicity, which is good for reliability.
Right. Yeah. I mean, having that option just to be able to go through all those different materials, the ups and downs of printing with TPU and flexible materials or those high end materials. Again, you're coming up with those problems that you didn't initially anticipate people having, but when people push your designs and your hardware to the limits, those things are brought up. So was that where Element came from initially? Was, you had the palette and then you came up with Element as a separate standalone, or did that kind of develop with the array as well?
Yeah. So we were actually we were in Chicago working with a technology incubator there and thinking about how we can have drive bigger impact and help have a bigger impact. And that was where it kind of all clicked in. Like I was saying before, we were seeing people buy palette for scaled 3D printing and automated filament changeover. And we kind of as a thought experiment said, let's go down that road for a moment. What would that look like? Back to first principles. How do you can 3D printing scale? Just asking that question. And why, sadly, when we heard from so many of those companies, did they not succeed in scaling 3D printing even with our palette? And I think really it came down to using printers that were fundamentally designed for human operation and not high volume human operation to try and scale them. And not the best example, but it's almost like if you had to feed a banquet hall of 500 people, you probably wouldn't buy a bunch of microwave ovens. That's just, you could, but that's
Right.
probably not the right approach technologically. And it felt like the same thing in 3D printing, using desktop, usually very low end printers to try and achieve industrial outcomes. So we looked at it and we said, what if you had a cost effective industrial grade printer? If you automated the three most laborious parts, so build plate loading and changing, material changing, and monitoring,
Mm-hmm.
the classic looking over, looking in the window, how's it going?
Right.
If you can automate those three things, you really only leave labor for maintenance, material restock, and harvesting of your finished prints and moving them to the next part of the assembly line, which any manufacturing process is going to have those three things effectively. So we really do get to that industrial grade of production process. So then we looked, okay, how do you accomplish that? What do you need? And 5 years later, I'm incredibly proud and humbled to be able to have Array in market and be able to show it off to customers and see it in their factories working. And so we kind of learned the recipe there was robotic automation. So kind of pick and place style automation to, first of all, change out build plates.
Mm-hmm.
So with the Array right now, there's what we call the storage cart. It has two sections. One section is empty build plates. It stores 40 of them. And then we have this pick and place robot that goes over, it grabs an empty build plate, it moves it over, puts it into a 3D printer that's baked into the Array system. It'll actually close a door, heat up the chamber, do all those preparatory steps that are needed, run the print, monitor the print. If anything goes wrong, identify that, flag that, pause, remove the print. But most of the time things go right. It'll take that finished print, put it onto a shelf in that storage cart, and then run the process again.
Mm-hmm.
And that's really useful when you're in the office. You can be focused on more productive things like working with clients, innovation, developing IP, growing a business, rather than doing those kind of monotonous steps. But it's even more powerful, at 2 a.m. or on the weekend or, on the 4th of July on a long weekend
Right.
when those systems are usually down. A lot of our customers report that in the absence of automation, they struggle to reach more than 40% utilization of their printer. And so that means that with the Array, because we can reach north of 95% utilization, each printer actually acts like 2.5 printers. And so the Array, which has 4 printers in it, acts more like 10 thanks to that automation. And you start layering all these things on, the automated build plate changing, giving you more utilization, the automated material changing, meaning that you don't have to have somebody there. You don't run out of filament to stop a print, the monitoring, the true scalability. You really get to a system that has a much lower cost per part and a much easier scalability factor when you need to get to 10 or 20 or 50, or in the case of one of our biggest customers, scaling to over 300 arrays. These are, there's some line in the sand where you go from prototyping to production. And I think it's
Right.
when you're at 300 arrays, 1,200 printers, 9,000 material pods, over 10 million print hours a year. It's well into that barrier of true production using 3D printing.
Absolutely. I mean, that's what we're trying to push here at Ascent Fab as well, is that, this can be used for production. We just need those very specific tools and automated processes in order to help us get there, right? So, yeah, when I first saw the Array, I kind of likened it to this industrial vending machine.
Yeah.
So kind of just for, visualization purposes, can you kind of describe, what this array looks like? How big is it? What kind of different moving parts are there?
That's exactly, yeah. A 3D printing vending machine, I think, is a perfect visual. Others will also say it's kind of, a 3D printing factory in a box. So you go over and you put filament in the material pods and you put them in, and you come back and you have this storage cart, kind of like a cafeteria tray style. Every layer of the tray has build plates full of parts. And so it really, it brings your cost per printing hour significantly lower than what's achievable on a manual system, certainly lower than what's achievable on, the old $250,000 industrial printer. And it's really interesting. We are not the first company to achieve commercial success with scaled 3D printing. Certainly, if we look at some of the important cases even a decade ago, the work that 3D Systems and Stratasys and Formlabs have done and others in usually small, high-end customized products. So think dental aligners, think jewelry. Those have been really perfect use cases because there's a high margin, there's a high need for customization, and they were able to overcome the old kind of milling, laborious process. I think the work that in O&P as well, it kind of is a step in a huge step in the right direction, in that the scale is much bigger. The value is still high, but it's not astronomically high. In fact, 3D printing is doing it in a more cost-effective way than the old milling methods. But what I think, it's really important for a lot of the industry who has a preconceived notion about 3D printing and where the limit will be, where it'll stop making sense, and you have to go to manual methods or injection molding or CNC machining. It's the fact that with Array, we get to that next order of magnitude where, I'm going to hold up a part here that I know most won't be able to see. It's kind of a bit of a boring part. It's a manifold connector, that's two different materials. This type of part traditionally would be injection molded, but for companies that don't have that scale to get to, $50,000 or $100,000 of tooling, or don't ever need to make more than 1,000, 3D printing was always an exciting option, but it wasn't cost effective because, it might be $20 or $30 a part. Now that we can do this for, 40 cents, 80 cents a part, you really do get to that point where the break even to injection molding gets up to 20, 30, 40,000 pieces. And it starts to make you question, why would we ever injection mold this? Unless, of course, you need to. So my point being that, if we look at the first use cases of 3D printing for production, they were very specialized, very niche, very lucky, high margin, small. Then we're seeing this shift over to O&P and automotive and certain lower volume applications where there's high customization. But we're very close, and I think Mosaic is pioneering the use for very high volume, sometimes boring internal components of parts, where it's true supply chain, true manufacturing. And that's a key building block to allow companies to onshore their supply chain in the US and Canada and Europe, and kind of break the mold of the classic, let's design it locally, send that IP overseas, and then get the product back via shipping container months later, very wasteful, not great for the environment. So this is a key building block to truly allow it to be a supply chain input to bring manufacturing back on shore.
Right. Yeah. You're having more companies, bring that vertical in-house now. Having all that production be done under one roof is definitely useful for, financial reasons, obviously, and turnaround time. And hopefully being a little bit more green to the environment, only using the material that we need and not, doing subtractive manufacturing in that way, in that sense. So with thinking about, so there were, was it 4 elements in the array, and what's the build volume of an element?
Yeah. So we kind of reached to make sure that it was quite big, but not too big to the point where it's not worth the money for most people. So it's 14 inches cubed, or 355 millimeters cubed.
Okay.
So pretty significant. But maybe the 5% that need something bigger will often break their parts up, parallelize production, maybe do post print assembly. On the O&P side, perfect for any type of orthotic, some prosthetics. Lower limb, we don't quite have the Z height, so that's not something that we focus on. I see the Film Innovations printer behind you is perfect. I think Mike and the team have done a great job on that. Yeah, it's so interesting. We had a group by yesterday taking a tour of our office, and in the office here in Toronto, we have 4 arrays, and one array is printing textiles for an emblem application. The next array is printing PEEK to print aerospace samples validation, working through a process with the company. The next array is printing fire retardant, I think it's polycarbonate parts as an input to a manufacturing run. And then the next array is doing a job for an educational group who has an array but has overflow capacity. They needed us to help them out get some student print jobs done. So it's that versatility of what it can be used for, because at the end of the day, while we sometimes talk about verticals, 3D printing itself is a horizontal, right? It's a manufacturing technology. It can be applied to many different applications. And something we wanted to figure out, back to your question, what's the right build volume? What are the right feature sets to build into a product that make it worthwhile for most people to invest in because it's useful for most of them? So multi-material, automation, a big build volume, high temperature, heated chamber. Those are some of the core aspects that we felt were kind of common to most applications and adding value. And then over time, of course, we'll bolster all of those things and get faster, get bigger. These things that are core to the objective of getting the cost of a part down and the throughput of the system up, so that per square foot of factory space, it becomes even more competitive with other options.
Right, right. And then if you have, some taller parts being printed, where the build plate goes out from the printer section and goes into the storage section, what is kind of that limitation then of like how many tall parts can you fit in the storage section before you have to interfere with the printer?
Yeah, that's a great question. That was a key design spec. So our goal that we targeted was 72 hours of what we call lights out production. So kind of a manufacturing term, meaning that the lights are off in the factory, nobody is there, the system is able to run itself for that period of time. Ultimately, it depends on what you're printing. There is this kind of self-regulating principle that generally bigger, taller things will take longer, and smaller, lower things might print faster. And that's self-regulating in that when you look at that storage cart, which has about 1.5 meters of height of storage, and then it's double depth, so you effectively get 3 meters of Z height of storage. If you're printing something small, you'll probably put more of them on the bed and effectively buying you more storage capacity because your density is higher. So it really does depend on the customer and their application. And through the process, when customers are scaling their factory with Array, our team is deeply knowledgeable on all this. We have models we can work with them on to understand, and to give you a sense, in some cases, they'll get a full week of lights out production where they don't have to touch it. Whereas in other cases, for example, 3D printing service providers, they don't really want to let the parts sit in that storage cart for more than 12 hours even, because they want to ship it and get paid and get it to their customers as fast as possible. So, they might be printing and speccing out their parts to not even give them more than 12 or 24 hours of capacity, because they don't value that density. They value getting the part done as quick as possible. Even in some cases, it's interesting. If you're a service provider, you might actually double. So you might need one part for the customer, but you'll send it to 2 printers just to have that redundancy. Because, as even as reliability goes up, 3D printing is never perfect. Any manufacturing process is never perfect, but having that capacity at your fingertips and being able to send parts through without taking on significantly more labor or cost is a really big game changer for companies when it comes to the reliability and being able to parallelize to decrease risk, if that makes sense.
For sure. Absolutely. As we, again, continue to scale, you're always looking to be able to maximize what you can output and minimize the input, especially on labor hours and financial costs and overhead that way. With that, again, with that in mind, if you are can you interact with the printer as it's printing? I know some printers, you open the door and it pauses everything, and then you're not at a loss, but you have to then restart it, and you might have some surface level imperfections. What parts of the printer can you interact with? Can you take some builds out to be able to take those off the build plates and then continue it back and just keep it rolling continuously? Or is there kind of like a stopping point where you have to let them run, they stop, you take everything out, and then fix it back up again?
Yeah, it's a great question. And I think the framing of your question is very much from the perspective of what printing is, the printers behind you. And I often think that way as well. It's, interacting with a printer on an individual basis. something that, and I can't wait for you to come up to Toronto or for you to use an
Yeah,
array
for
for,
sure.
and something you'll feel and see is it really makes you think about 3D printing differently. You no longer think about an individual printer. You really do start to think about it as a capacity. You throw the job in through Canvas, our software. It asks you, do you want to print one? Do you want to print 30? Do you want to print 300? You send it through, and then you kind of lose track of which printer did it get sent to, because it's taking care of all that thinking for you. It's checking if you have enough filament of the right filament at the right printer. It's choosing which printer to send it to. The robot is doing all that for you, such that it's no longer you going over to a printer to grab a part. It's you going to the back of the array, which is kind of the safe side that as an operator you can interact with. There's no robotics or anything like that. And it's just which shelf on the storage cart is your part. And it'll actually show you on the screen. So it's like, okay, shelf L4 is this client's part. I'm going to grab it. So yes, absolutely. The moment that print's done, the robot's putting it on the shelf for you. You can grab it and go use it. It really is different than interacting with the printer, watching the first layer yourself, taking a little brush and cleaning the nozzle. We've had to overcome all of those manual steps that kind of incline you as an operator to feel like you need to be involved. Part of scalability and automation is, even if it takes a bit longer for a startup process, building out these components of the system. For example, we have something called the densifier. It's more sophisticated than your usual like brush. It actually lets you extrude filament into it. It densifies it into a blob. It moves it away from an entry into a waste reservoir in a really dense way, so that you don't have to like go over with a brush and get rid of any leftover filament in a nozzle. Helps clean the nozzle, get the print going. We also have, we're I think one of the first to bring to market a load cell based build plate, meaning that when we're homing to get a mesh of the bed surface, we're using the mechanical tip of the nozzle crashing into the bed very lightly to get a true surface that is independent of a pin to probe or a EL touch or how hot the bed is or how much glue you have or what surface. It's getting the true distance between the nozzle and the bed, meaning that Z offset calibration with paper, sliding a gauge in there,
Oh yeah.
that's a thing of the past. And again, that is necessary for a system like Array, which is fully automated and really brings the barrier from an operator perspective much lower, because you need to be able to load filament and grab your load filament into a material pod and grab your finished parts versus doing all those usual steps that someone like you or I would be used to doing when running a 3D printer.
I mean, I don't have to push paper underneath the nozzle anymore and, do all those preparatory things before I start a print. That probably cut out at least 10 to 15 minutes per print, and in some of these prints, like, the Fill Innovations printer, obviously, there is a little bit of manual manipulation if we're going back and forth between different size nozzles, a very quick and easy, Z offset. But for some of these lower level printers, yeah, I have to constantly manipulate that because the bed sensing technology isn't as great. So it might be slightly bent over time, and then it's going to be skewing some results of how the bed leveling is. And being able to actually physically touch the bed with the nozzle and getting that true depth, I would think would be a little bit more straightforward, right? I mean, has that been implemented on several other 3D printers now? I think I've heard of it maybe in passing, but
it has, and there's no surprise there. I mean, there's some good innovation that's coming in the market now. I think there was a lot of stagnation for a while, and now we're seeing a lot of improvements. And it's getting past these pain points because I think there's been a saturation of maybe engineering use cases. And as it pushes to sort of more broader creative applications and companies, the industry needs to get past this notion that you have to be an expert to use a 3D printer. And so, physical
right.
touch-based homing, more reliable extruders, better filaments, more integrated experiences where the expectation is that you put something in, hit go, and it works, not you needing to be the person who does like a 9-step slicer setting calibration.
Yeah.
But I think it's so many of the things that we've touched on already. For people who haven't been in 3D printing for 5 or 10 years, or even 3 years, they likely have this notion that it's for experts, it's slow, it's expensive, it's not a production technology. And I think rightfully so, that was true. You add up all of these things from much more reliable systems that are not dependent on the subjectivity of an operator, making the skill level lower, the cost coming down, throughput going up, significant amounts of automation, and you end up in this new paradigm where 3D printing is being used. It's not will be, is being used in a broad range of production applications, pushing up to that, again, 20, 30, 40,000 piece mark. And I think we're in an exciting time in the industry where if somebody enters today, they will be a little bit blurred and confused by this transition phase in the market. But I think 5 years from now, dominantly additive will be used as a production technology, and it'll eclipse the prototyping and one-off applications, which for the past 30, 40 years have dominated the landscape and the narrative. So, we're living through it right now. It's, of course, from Mosaic's perspective, we're helping drive that with the ecosystem of canvas and materials and the array system and the Element 3D printer. But 5 years from now, I think that there will be a lot of players in the space, because you're breaking out of the 18 or 15 to 18 billion dollar 3D printing market, and you're moving into that 16 to 18 trillion dollar manufacturing space, which is so much bigger and broader. I think that line between them is really getting blurred.
Right. Yeah, we're in a new industrial revolution here. We're in the additive manufacturing revolution. I think having that next level production status, having more options for continuous printing. I'm also a distributor for Black Belt, the conveyor belt printer. So I'm already getting some ideas here with the pallet and Black Belt, and maybe we can see what comes up in terms of some collaborations with the array as well in the future here. But I'm pretty excited about more automated level printing, because to your point of being able to automate some of these steps that require a little bit more training, more specialized training, to be able to dictate to someone else of my 9 years of 3D printing experience now exactly what to look for. And sometimes that's a little difficult to convey to someone, like, oh, it's got to look this specific way, right? But in terms of like the slicing software that's out there right now, I think has a long way to go. It's already coming up little by little every year, but on the software side of things, and then the hardware, a lot of these more specialized parts of the process can be automated, and it's awesome to see that you guys are helping to lead the way in that respect. Could you speak a little bit to, I guess, kind of the software that you've come up with to help some of this automation, and have you done anything specific with just name brand slicing, or have you kind of created your own partial slicer as well?
Yeah, great question. So when we think about the software package, so we have a cloud-based software called Canvas. Been developing it for, I think, over 7 years now. Started with supporting multicolor with palette, but what we realized is that when we flash forward and we think about the importance of software in the workflow, it very much is the front end to everything, because the robotics now take care of the back end of printing and all that. It's really important that the software be a full experience. Slicing traditionally has been very dominant when we think 3D printing software, but it's kind of like a driver that runs in the background. We think about an experience of bringing a file in and having file management, project management, getting in and preparing a file, doing that slice, but then that's kind of a blip in the process. Sending it to the appropriate printer, monitoring, collecting data, keeping track of what materials are where, what build plates are where. That is all done right now in our Canvas software. So it really is, whether you buy an Element printer and you're doing desktop printing, prototype validation, or if you're using an array and you have to be managing, somewhere between 4 and over 100 printers, that entire experience is covered in the Canvas software. And again, it's just one more chip away at the reasons that people struggled 5 years ago to buy 100 printers, put them on shelves, and call it a factory. If you're using a slicer and slicing and putting it on USB drives and trying to manage all of it, going over with your paper to level the printers and remembering which one's on this firmware and that firmware, I feel for those companies, because they had the best intention, and some of them were able to make it work, but for most of them, the costs were way higher than expected. The reliability was much lower. And I think it was a great experiment to set up the opportunity for array today and the Canvas software, back to your question, that effectively is powering the entire factory.
Yeah, no, that's awesome to hear. I mean, again, in terms of automating the slicing and setup process is something that I think is very much needed. And then I think you spoke a little bit about some monitoring of the prints, during the print. Does the array do any of that by camera or by other means right now?
It does, and we have a team continuing to work on this. Philosophically, the way that we think about our products right now is we're building an ecosystem, and getting them into the market doesn't mean we stop working on them. In fact, it's kind of the beginning of focusing on reliability and using the products and the sensors that are there to create an even better experience. So I believe there's 11 sensors in each printer, all the way from your load cells to your high precision filament linear motion monitoring in the print head, humidity, you name it, looking at that data, and then the camera, and using that and some machine learning to be able to, with a high degree of confidence, identify risks or problems, to give you confidence as an operator that you don't always have to be watching everything. So yeah, that's a really important part of the system. And like I said, something that we're going to continue working on and pushing out, so that those with arrays already today, those who are getting their array tomorrow, and those will have it in 5 years, it'll constantly be getting better. And as we get more data, it reinforces the algorithms and makes it more reliable. We are in the business of helping our customers print at high volumes reliably. And if we can push out a software update that helps make the equipment even more valuable, that's a win-win for everybody. So that's kind of going to be our approach.
Right, for sure. Yeah, being able to continue to, make the existing printers that are out there even better simply due to software or maybe some hardware tweaks is definitely, interesting because, these printers at some of the price tags they're at, you don't want them to be obsolete in just a few years. And with how, quickly this space is growing, some of these printers are already obsolete and they're already working on, version 5, version 9. So it's interesting to see kind of that development and how versatile some companies are being right now to be able to make those changes on the fly to existing printers. So that's great that you guys are thinking about that as well. I know, getting back to like the visual aspects of like seeing if a print is going wrong, right? I mentioned the cameras. We've got a couple cameras on, some of our printers just so I can look in from home and, a few minutes down the road from my office to see, is a print messing up? Well, I should go, get out of bed and drive down and try to stop it before it, wreaks havoc or, gives me a bird's nest. So, are there any specific, pinpoints in the software there that identify problems that are going on potentially? I know some companies are starting to look at this, like I believe AI Build is one software company doing more so non-planar 3D printing, but with robotic arms. Is there anything like that currently in the software or something similar?
There is. Yeah, our culture has always been to under promise and over deliver. So we don't like to announce things until they're very close to coming out. So I won't say too much about the specifics, but at a minimum, the ability to notify you, hey, go check printer 46. We think there's a high likelihood of an issue. The other ones are very low, like you don't need to look at them. So in your exact example from home, you pop into Canvas, you pull up the camera feed, or you look at the exact notification. It might say, filament extrusion was 10% less than it should have been for the last 10 minutes. Something's probably wrong. Maybe there was an imperfection or the nozzle got clogged or something like that. And then you can look at it, and then taking it one step further, you can actually cancel the print, have the robot remove the build plate, put a fresh one in, change out to a new spool of filament, and run the print again,
There
all
you go.
automatically.
There you
Right?
go.
So
Yeah.
we always want to be careful that we don't have a false positive. We don't cancel a print that's good, maybe
Right.
using peak filament, which is incredibly expensive. Finding that balance so that as a user, you have the permission setting ability to decide what actions you'd like to be taken in certain cases. But when there is a failure, the ability to, as quickly as possible, recover, that's again a huge part of that uptime. Because sure, a printer can be used 100% of the time when it's if someone's there always running it, but realistically, no one is there running it. And so when something jams or breaks, if you have that single point of failure on your system, you can have a lot of downtime. But thanks to the ability for array to detect that and actually recover itself, that goes a huge way, in addition to just changing out build plates.
Yeah, no, that's definitely a huge step in the right direction for, print monitoring and making sure that we're not wasting too much material or, having that false positive, which I'm sure, percentage wise is going to happen, right? But, hopefully a less percentage than the number of prints that, just go wrong, and it's a 60-hour print and you're done at hour 50 because something went wrong. So, that's cool to hear. So what do you think, not slightly off topic here, but kind of on topic still of the slicing, what do you think about having a slicer that will more so take a look at your part, analyze it for printability? Right now, the slicers that are out there right now, they might maybe indicate color wise if you have an overhang angle potentially, but unless you actually visibly look at that thing and know what you're looking for, you might not know what to change on the back end. So this is kind of just a more general question, but what do you think of that kind of machine learning that goes into the slicing techniques and slicing software that's out there?
I think it's incredibly important. I think there's so many of these building blocks that are incredibly important. And when we think about that upstream process of CAD and design and assets, even upstream one level more of a model being brought into a slicer, what about rich assets so that somebody can take a free course or ideally even learn it in school about design for additive manufacturing, right? Because I don't think we have to be apologetic for the fact that there is a way to design a part that'll print more reliably, be stronger, be lower cost, all those important things. Just like if you're going to CNC machine a part, you're not going to have blind pockets that can't be reached by a tool. If you're going to injection mold a part, you're going to have constant wall thickness. Most manufacturing processes have incredibly stringent constraints that we're quite used to. But in the world of 3D printing, I think sometimes the thought is like, oh, like you should be able to print anything. And with support material and all that, you can, but that doesn't mean that there isn't a worthwhile exercise in design for additive manufacturing. Once you get one level past that, brilliant. I love that. I think there's a few companies working on it, taking labeled data sets of models that printed well and didn't print well. On the Mosaic side, we're building interfaces that you can tell the printer if your last print went well, what went wrong, and we'll certainly look to leverage that data for things of this nature. An interesting pattern that I've seen that was maybe we should have anticipated, but when somebody's using Array, there are use cases where they will print 200 different models in a day on the system, but very often it's bulk production. Whether it be for student projects, where sure each one is different, but generally they're in like the same volume, same base model, depending on what the project was. But then in production applications, if someone needs 60 cable harnesses or 4,000 L brackets, typically what they'll do is they'll print one full build plate. They'll monitor it, or maybe 10. And if they find any issues, they're likely going to find it in those 10. Maybe it's that they need to add a brim or a skirt or try a different orientation. And so you kind of do get this learning in that first print. And then if those first 10 go well, there's a good chance the next 500 are going to go well as well. So right. The kind of good news there is that you can leverage the expertise of somebody who's on the design side and getting the print started. And then once you achieve that success, typically it's that scaling part that Array can say, all right, leave it to me. I'll take care of this. It's not quite as bad as you might expect, where every single part needs a lot of attention, if you know what I mean. Even in your world, sure, an anatomically customized lower limb socket or foot orthotic is slightly different, but generally speaking, you're going to be able to template the slicer settings, the orientation, those best practices, and that would apply on Array as well.
Right. Yeah. Design for additive manufacturing is a term and, idea and way of thinking that I've been trying to instill into a lot of my customers, because again, people are just learning about 3D printing and some are just getting used to looking at CAD software and figuring out how to go from that, positive limb shape scan to a negative, design that we can 3D print. So, that's definitely something that we're trying to help along with some of our, in-house trainings and education on different printers and software. So, we're trying to help, lead the way in that respect, and just push that forward, because again, with what I was mentioning at the beginning of this episode, the 3D printing something that's definitive in nature, something that's going to be used on a patient for a long period of time, we want to make sure is as robust as possible from, our background knowledge in physics and engineering and our clinical expertise and what we see works on a patient with, similar attributes that patient is showing. So I guess on that note as well, how have you been involved with the O&P industry, if at all now? Gotta have a little bit of O&P flair to this as well.
Absolutely. Yeah. So, I mean, preaching to the choir here, you know this just as well as I do, but, you know, a very important space when it comes to patient outcomes and how it can impact so many parts of a person's health. And therefore, it's no surprise that it almost seems like, 1 in every 3 or 2 in every 3 people wear a foot orthotic. And if we look at the central fabrication adoption of new technology and the way that so many of them are still making orthotics, it's proven it works, but it's very laborious. CNC milling, thermoforming, bandsawing, sanding. A lot of them that I've spoken to are really struggling with scalability. They're struggling to find labor. It's not general labor. It's like very specialized, almost on the edge of art to do this type of production. And you're starting with the digital input. A lot of them have adopted scanning, but then it's kind of still going to this subjective hand-done process. It's pretty wasteful, can be pretty slow. So the idea of going from digital scan to 3D printing, there's been some really great HP's done a lot of work in the space. There's a few other players, but the cost incentives haven't been that great. There's a huge capital expenditure to buy these large printing systems, and the cost per part, because the consumables are a bit expensive, is still quite high. So what we've been able to do with the array system is, I'll hold up here an orthotic that is able to be customized, printed in just a couple hours. So the array system is able to do these very cost effectively, usually in the roughly $15 per pair, all in, which can put the power in the hands of a practitioner, or at the central fab level, because of the automation of array, can trivially let them get more capacity. Yes, you still need labor. People need to run the systems, process the files, but there's amazing software out there like the Printed Foot and many others to be able to do that. So what you end up with is helping companies, CFABs, really get that full digital experience that helps them scale as businesses, leads to better patient outcomes because we have a more repeatable outcome that's digitally defined. It should pass cost savings onto them, making it more accessible. So there's really a ton of good stuff going on. We're going to be at AOPA in I believe September, looking to meet with lots of other folks in the industry. And this is an exciting one. I think it's high impact, and I think that we can overcome this perceived barrier of hugely expensive equipment, very complicated to use, very locked down, and not huge cost benefits, to a system like Array, where it can be deployed for well under 100 grand, which is like 5 times less than other systems, can be printing parts that are vastly lower cost than any other printing method or the manual method, and really help companies get that entire experience end to end.
Right. Yeah. Having that ability to, again, just scale up production for, some of what we're seeing in the prosthetics and orthotics field, with lowering reimbursement rates from insurance companies and higher costs of providing care, are really kind of squeezing the the emphasis on the fabrication, how we are actually making these devices. When it comes down to minimizing our costs, it's really in that labor cost aspect of things on the fabrication side of things, but also the amount of time that is spent with a particular patient. So being able to go into a digital workflow has been very helpful in that respect. Going from 3D scanning through modifying something in a digital software and moving towards 3D printing has definitely shown to be extremely cost effective in a lot of different ways. So we're pretty fortunate to, again, be in this space to help lead that charge, and again, find more use cases for different types of printers and solutions that better affect some of these devices that we're putting out. So such as foot orthotics, we are providing foot orthotics through Ascent Fab and using a number of different materials, having that process be a little bit more automated to scale that production is something that we're, looking to definitely get involved in. Have you had, actually an array implemented within the field yet, or not quite yet?
Yeah, so we're at an exciting phase after 5 years of developing all the technology. We're just closing out a pilot program right now, which has a bunch of arrays out, some in the US, some in Canada, and then a bunch more of the Element desktop printers using all the feedback, implementing new features, improvements, reliability fixes, you name it. We always believe that great products are built, alongside great end users, rather than just guessing what people want to do. And in parallel, we're ramping up, or near the end of ramping up production. We're actually making Array and Element in Canada, which is exciting and sort of living the vision of many of our customers and bringing manufacturing onshore. And so a little bit later this year, big backlog of early investors in Array and Element are going to get their printers, and several in O&P. And then, we're really expecting to scale up from there. Something we find oftentimes is, a company will say, hey, I want to start with 2 arrays. And then as I prove out the economics, a few months later, I'd like to scale up to 6 or 8 or whatever it is. So, the fact that array is inherently being bought for production, it plays really nicely into the business model of being able to help companies scale. And as they win, we win.
Right.
There's also another aspect that where I thought your question was going before, the specialization of applications. Something we see is that there can be a disconnect between a truly compelling digital manufacturing application and someone just buying a bunch of printers, whether even, if it's array and if they're in ecosystem material and software. And it's that middle step of figuring out how to implement it, figuring out how to do that design for additive manufacturing to get things more lean, get the cost down. And sometimes it's like basic stuff like that. Sometimes it's a lot more sophisticated. Maybe it's developing a special print head or making a filament that's really hard to print reliable. So we've built out a group called Mosaic Solutions, and it's effectively meant to act as a consultant to some of our most compelling customers, where they can effectively get members of our team to work with them for a period of time, on their exact application. And we usually do it when it's strategic, when it'll kind of help open up an industry or really help our customer. So we have a few of those projects going on right now. One of them is actually in the textile space. So my shirt that I'm wearing right now, this is actually printed with an adhesive, can be attached to the garment, and developing those materials and that process really took, I think it's been 5 full-time applications engineers on the Mosaic team for a significant amount of time, but it can unlock $100 million industries for different customers. So if companies do have applications that they're looking to scale, and they feel that barrier is maybe the lack of expertise, there's companies like Mosaic who have Mosaic Solutions, and other consultancies out there that can really help get that done. And I think that's going to be a really important enabler, just like how in the automation world you have tech integrators who really help bridge that gap. I think that we need to see more of that on the additive side to help bridge the gap between compelling application and technology.
Right. Yeah. Having that, again, that design for additive manufacturing approach, and being able to talk with people intelligently about how to bring an idea or a product to that production level status, I think is something that's still being, further investigated in terms of, different companies are going to approach that different ways, how they want to produce an object. So, being able to work with a team like yours on that is definitely very, very helpful when a company is looking into purchasing an array, or multiple arrays. That's definitely an exciting aspect to think about. So, well, yeah, with that, with all that being said, with the different applications that array and pallets, let's not forget about pallet we talked about earlier. Might want to talk to you a little bit more about that later.
Yeah.
With all these different applications, it sounds like you guys are really at the helm of, leading that charge into automation. So, kudos to you guys for taking that on. And, I'm really excited to see the progression in the O&P field that Array might have, as well as helping to maybe be able to support that and then, see what other industries you guys get into, because it's really exciting stuff. Again, just kind of scratching the surface to automation and some of the, more hands-off approach that we could have to some of these printers. So that's awesome to see that you guys are leading that charge. What's the best way for people to contact you, to get a hold of part of your team, and to learn more about the array?
Yeah. Always open to have conversations. Love engaging with the community. So easiest way, feel free to message me directly on LinkedIn, Mitch Debora, Debora. Give me an ad. Let me know you heard the podcast and want to chat about anything. If I'm the right person, can speak. If you have any questions about product, can connect you to a product expert. mosaicmfg.com, like mosaicmanufacturing.com. Can learn a ton about array, element, palette, canvas. Canvas is free, so you can you can use it, try it out. It's a slicer that works with most printers. There are some paid features when you get up to array, but for most people, they'd be able to give it a try and sort of get value for it right away for free. And really appreciate you having me on the podcast, and hopefully I'll see you. Will I see you at AOPA?
Yeah, we're taking a look at September to see how the next couple months go. I've been thinking about it. There's going to be a lot of digital aspects to AOPA's conference this year. I know last year it was huge, just kind of exponentially grew from what it had been years before. So that's definitely exciting to see that, more and more people are getting interested. There are more companies coming to the P&O field for these conferences. So yeah, we'll take a look and see. If we don't see you then in September, I'll definitely make it out to Toronto here soon to try to come check out your lab there with all the different arrays going. So yeah, we'll definitely get in touch soon. And good luck there at AOPA if we don't see you. But are there any other conferences this year that you guys are looking to be at?
Yeah, there's a few. So we'll be at AOPA. We'll have arrays there and the team and samples and everything. So that'll be a full display. We're going to be at the CMTS, Canadian Manufacturing Technology Show, out in Toronto, also in September. And then we will be at Formnext in Germany later in the year. Again, always having arrays and elements out there, printing live on the show floor. So a great time to connect and for people to see the technology.
Very cool. Very cool. Well, yeah, Formnext is definitely on my list as well. Getting out to Germany there at some point. So, well, thanks again, Mitch, for taking the time out of your day today to go over everything, the palette, canvas, and array here with all the elements inside of it. So, great stuff. Looking forward to seeing what you guys do here in the future, and looking forward to collaborating with you guys in some way, shape, or form. But thank you, everyone, for tuning into today's Fabrication Friday podcast. That's it for this week. Tune in next week for more awesome 3D printing stuff. All right. Have a good one.
Thank you.